Okay, so yesterday we got through average rate of change, which remember is just slope over an interval for a particular function. So today we're going to finish up and we're going to talk about secant lines, and that's a geometry concept. So a secant line. Does anybody remember what a secant line does in geometry? There were secant lines and tangent lines, and you did this when you talked about circles in geometry. That was a tangent line that went over the top. A tangent line only touches the outside edge of the circle. A secant line intersects the circle in two places. For us, a secant line is going to intersect the graph of a function in two places. Out of that, that's what our secant lines are going to do, and they're just going to be slope-intercept form. Y equals mx plus b. We're going to have an interval, and they're going to get two intersection points. Okay, so for example, J, we used this function. We used f of x was 2x squared minus 5x over 1 to 5. Okay, and we did all that work and we found that f of 1 was -3 and f of 5 was 25. All right. So all that work that we did yesterday, not in vain here. So we found those. Is that what we found? Let me make sure those numbers. F of 5 is 25. Yeah, that's right. We did. And then to write the equation of a secant line. So what those 2 points end up being are the points of intersection. That's where the secant line intersects the graph of 2x squared minus 5x. Remember, 2x squared minus 5x, it's a parabola shape. So what we're going to find is the equation of the line that runs into that parabola in those two places. Okay, that's what we're finding is the equation of that line. So to find the equation of a line in slope-intercept form, you need the slope and then the y-intercept out of that, right? So that's the two things we got to look for. So we're going to take those two. We're going to find that slope, which is the average rate of change that we did in the example yesterday. It's the same thing. So 25 minus -3 over 5 minus 1. That's that slope formula. So that'd be 28 over 4, which we found the slope to be 7. Okay, so we have part of our equation, y equals mx plus b. We got the slope part. How do we find the y-intercept part? Plug in a point. Pick one of those two to plug in. It doesn't matter which one. I'm going to plug in the 1, -3. And then solve that equation for the y-intercept. It'll be 7. And then subtract 7. Because I'm plugging in the x and the y. So I can find b. No. 1 goes with -3. The ordered pair was 1, -3. Subtract 7. You get -10 as our y-intercept. So our secant line is y equals 7x minus 10. So a secant line, again, intersects in two places. They're going to give you the interval to find that over. So they're going to give you the two x values to start with. You're going to find those ordered pairs, and then you're going to find the average rate of change, the slope, and then the secant line is the equation of the line that does that. So looking at the graph of 2x squared minus 5x And then I'm going to graph the secant line as well, which was negative 7x, not negative 7x, positive 7x, minus 10. That's where the negative is coming from. And I just want to show you what that graph looks like. So we see a parabola. We knew the 2x squared. That's what that looked like. And then this secant line, the first intersection's down here at the 1, negative 3. And then the other intersection's just off the screen there. If you wanted to zoom out to see that, you could. But we can tell that that red line is going to intersect the blue one out of that. So that's what we're finding here. So if you ever graph the original function and the secant line and you can't tell that it's going to run into it twice, then you might want to check your secant line because it may not be right. Because the secant line always intersects twice. So you got to check your signs. If it's not intersecting the way you at the places that you said, then it's probably wrong. Okay, let's do another one just all the way from the beginning. So we're going to find the equation of a secant line for f of x is equal to 3x squared minus 2x plus 3 over negative 2 to positive 1 . So new function, new interval. So we're doing everything from the beginning here on this one. Writing the equation of the secant line. So what's the first thing that I need to find? In order to find the slope, what do I need to have? Got to have two ordered pairs. So I need those intersection points. Where is this secant line hitting that graph? So how do I find those? Plug these in for x1 and x2. So f of negative 2, plug that in and work that out. If you want to use the calculator to do that, go ahead. I mean, whatever how you want to do that. You know, if you can store negative 2 as x and then type in 3x squared minus 2x plus 3 if you want to, or you can use the table on the graphing part. I don't care which way you do it. I'm going to do it by hand without the calculator just because I don't think it speeds me up that much. Okay. Okay.
So with, like, for example, the 3 and negative 2 squared, which do you do? Do you square it or multiply it by 3?
Order of operations says parentheses, exponents, multiplication, division. We follow order of operations, so exponents is going to come first. So that's going to be 3 times 4, which is 12, plus 4, plus 3. Be 16 and 3 be 19. So f of negative 2 is 19. And then I'm going to find f of 1. Not plus, but minus 2 times 1. 3. So that's going to be 3 minus 2 plus 3, which would be 4. So ordered pairs are negative 2, 19, and 1, 4. Then we find our slope. 19 minus 4 over negative 2 minus 1. 15 over negative 3, just negative 5. Just using the slope formula there. And it doesn't matter which one you call y2 and x2, and x1 and y1. It doesn't matter because as long as it's in the right order, the 19 and the negative 2 are together, and the 4 and the 1 are together. So then find the equation of the line. So we got the slope, negative 5x. We want to find the y-intercept. That's all we got left to do. So pick an ordered pair. I'm going to pick this one over here because it looks easier. It'd be negative 5 plus b, and then add 5. 9 is equal to b. So the secant line is y equals negative 5x plus 9 for that particular interval. If the interval is different, then the ordered pairs are different, which means the equation should be different. It's got different intersection points. Okay. You can verify that by graphing the original function and the secant line and making sure they intersect at the same places that you found. If they don't, then you probably miscalculated somewhere along the way there. So secant lines aren't hard to do.